Hello, my wonderful BC students. This is 2011 Form A, number 3. So let's do this. So part A, we want the perimeter. So the perimeter, we're going to add up a few distances. That distance, that distance, that distance, and that distance. Not too bad, eh? So the perimeter okay, let's do this by color. The distance down here, that's just K. And then that distance there, that's just 1. And this distance, that's simply e to the 2k. Now, the fun one. What's that distance? Hopefully you all remember the formula for an arc length. So you have an arc length of a parametric, arc length of a polar, but those aren't being tested. But this is an arc length of a simple function. So arc length, as a reminder, is the integral, and it's going to be square root of 1 plus f prime of x squared dx. So we would add integral from 0 to k, square root of 1 plus. Now we need f prime. So f prime of x, I'm going to write this, it's e to the box times derivative of the box. So we're going to put 2e to the 2x power all squared dx. And I don't think they wanted, yeah, you don't have to simplify that. We're done. We are done ito. So as long as you knew this formula, piece of cake. If you didn't, piece of turd. All right, let me erase stuff magically that all disappears. So we're rotating this around the x-axis. So let's get circles. Rotate this. How do I move this whole thing? There we go. So we're getting a bunch of circles. And the first one is right there. And the last one is going to be right there. So how do you find this volume? So to find the total volume, you have to add up all the volumes of each disk. And we're starting at 0 and ending at k. But what's the volume of any shape? It's the area of the shape times the thickness. Now, how thick is one of these disks? It's going to be a change in x, dx. So we will do pi r squared, that's the area of the circle, times the thickness, which is dx. But now the question is, what is r? R is that distance, but that distance is just that function. So let me rewrite this now. 0 to k pi. It's e to the 2x squared dx. And I need to simplify this. So the pi comes out in front. It's going to be e to the 4x squared dx. Whoops, the daisies. I don't know my basic algebra skills. I was kind of freaking out. I was like, I can't take this antiderivative. But then I realized, me not so smart. So an exponent to an exponent, you just multiply that. You don't square it, dummy Yoshida. So that's just 4x. This is a simple u sub. U is 4x. du is 4dx. And now we ask the question, do we have 4dx? Now you do. So that becomes u, that becomes du. So this becomes e to the u du, but these are x's because our variable is x. We need to change them to u's, so plug in 0 to x, u is 0. Plug in k, u is 4k. Now, the antiderivative of e to the u is just e to the u. Now we're going to plug those in. Which is, now you can factor the pi over 4 out. You don't have to. I guess I just will because it's prettier. That is my answer. Done. Par B. Move on to par C. Let me get rid of a lot of this stuff here. And I guess I'll put a big box around this stuff. Whoa, that's not a box. That is a box. Can I get this to scroll down? I'll just change the shape of the box. Oops, too much. All right, part C. The volume changes as K changes. So we want to find out how fast the volume changes. We know K changes at this rate. Oh my, I erased my previous answer, so let me write my previous answer down. Volume on the previous answer was pi over 4 e to the 4k minus pi over 4. So here is the deal. We know the rate at which k changes, and we want the rate at which v changes. In respect to t, t is our variable. So what you have to realize here, v is a function of time. K is a function of time. So those are actually functions, not variables. My variable is t. So I have to take the derivative of this function with respect to time. Well, the derivative of v with respect to time clearly is just dv dt by definition. So we have to take the derivative, well, this, derivative, that's going to be 0. We don't need that. We need the derivative of this, but we need to see that this is actually box. It's a function in a function. So we take the derivative, the constant just gets copied. What's the derivative of e to the box? Well, that's just e to the box. Then we need to multiply by the derivative of that. Well, 4 is a constant. We just copy that. The derivative of k with respect to time, by definition, is just dk dt. Now I plug in my known values. So this goes here. K is 1/2. That's going to go here. So dv dt is pi over 4. E to 4 times 1/2 is just 2. I'll do that. Times 4, and dk dt is 1/3. That's it. Now, I urge you to stop there. Some of you OCD crazies need to simplify. Please don't, because that just adds to the possibility of getting this wrong. So we have a pi left over, e squared left over, and a 3 on the bottom. There is my answer. Done. That actually wasn't too bad of a problem. Hope you enjoyed that. Bye.